Now, this is a supplementary video, and in this video, I'm going to try to show you a strategy, and it's probably a useful thing for you to do, but only do this once you've gone through the other video and the other exercise. Once you've built this and this all works, here's a little trick. What we're going to try to do is take each concept and put a separate function or a method, helper function, which does that work for you. You will have done strategies like this before in your previous study. So let's have a look at this very first block. This whole block is all about, well, no, that's our input. This block is all about getting a size. Okay, so what happens if I create a helper function? Let's find some more space down here. And static void. Now these are public static voids. They're not returning anything and they're sitting inside this place. Let's say I create a method called getSize and I pass it a string, and watch what I do. I take that, please enter an integer, as that's going to be my string. Okay, let's grab those lines of code, not those lines of code, sorry, those two lines of code, and let's pop them in here and edit them. So instead of a concrete bit of text, I'm just going to put in the string, whatever string is going to be my prompt. Okay, that's going to get the next integer, but instead of just holding it there, I'm going to return that back to whoever uses this particular getSize function. Right now, you might ask, what was the point of that? Watch carefully and see if you can grasp what I'm at. So I've created a getSize. So if I replace that print statement there with my getSize function, right? And I pass it, let's take that from there and store the result, the return value from the getSize, and get that out of sight. I want you just to have a look at what I've done. Now, there are several advantages of what I've done, and this is going to be critical when we talk about complexity. One of the fundamental features of getting your head round Java is all about, and I'm anticipating, is complexity. One of the strategies we do is we break up code into methods and functions to manage complexity. And we do that in this way. We take the concept of what we're trying to do, which is often the name of the method, right? And the body of the method is the mechanism. It's the how we do it. Okay, now that strategy will come back again and again and again, but what it actually lends yourself is that you know what the method's got to do. You've got to get the size, so you call it getSize. So the concept and the name are almost identical of what you're trying to do. How it does it is in the body of that particular method or function. Okay, so have a look at this. I've created a method or function. I give it this piece, this prompt, and it gets the size. When I look at that line of code, I don't know how it does it. And the important concept is I don't need to know, right? But keep that in mind. That's the concept, and it's giving back the result. If I come down here, so we look at the mechanism is it receives the string, it outputs the string, and it returns using the scanner. Now that's not going to work. And we'll spot why it's not going to entirely work. So we will discuss that in a second. It's trying to, well, let it throw the error because there is an error. Now I'm going to leave that error there and see if you can spot what it is. If you can, it's very good. But let's watch this error appear. But let's keep the basic idea that we're at. Void cannot be converted to an int. Okay, that's one other issue. But what the input is declared out here. How can this getSize function get access to that particular method? It's not inside here. I'm trying to use input. It hasn't even actually arrived there. So what I do is I want to I'll copy this out for the time being, and I'll drop it into here. So inside the getSize, as part of the getSize mechanism, it will declare the scanner input. It will ask for it. And the second error, void cannot be converted to int. Void means it's giving nothing back. Look here, it is giving an integer back. So I need to change that to int. Right? So here is a bunch of mechanisms, how to do something, how to get the size, right? That's what you're trying to do. So look back up here with a tiny bit of change. It now does that for you. Run it again. Let's test that it works. We'll test it with a very, very simple example. So we say 3, take 3 random values, and you can see that it's displaying it in the loop. Okay, that's part of it. Building an empty array is fairly straightforward. Perhaps you might want to think about, is that concept clear to you? That hopefully is now clear what it's doing. Now this bit is a nice little block of code, which is a mechanism. It's a process, and we want to hide that process under the concept. And in hiding that, tab 9 on a Mac incidentally needs to have permission to access folders as it's working. So I want to take that mechanism and I want to put it as, I want to know what the concept is. It is to populate that array. Okay, so let's copy that and let's see if we can create a another helper function. And what we'll decide in a minute what we're going to give back. We're gonna, so it's a public static. Let's start with public static void and try to work our way. Now, what's the concept? It is populate array. Okay, we'll work out what we're going to pass it in a second as a question of need. Now, this is still a little bit of an advanced set of concepts. So you have to only proceed with these if it makes sense. Now, index is a value internal to the for method. The array, it clearly needs access to if it's going to populate it. So we need to, if we're going to use it, we need to get hold of the array. Okay, so we need to pass that, the array, in to our populate array. So it needs to receive the array. What else does it need? Well, it clearly uses a next line, so it needs to have a scanner inside it. So we grab that, pop that inside the method, but not in the loop. Okay, so it's almost complete. We no longer need a general scanner, right? We no longer need that. And what we're going to do is we are going to replace all of this. Now this will be very interesting. I'm going to comment all of this out. Okay, let's go to my edit comment. Where is my comment? Okay, so I've commented it out. Now, what happens if I simply execute or run populate array? I'm not returning the array, I'm just passing it in. You have to pay attention to this because this is a very, very crucial concept. I now pass my integer array in. Remember, I don't have to declare it here. I'm just taking it and I'm passing it in. The populate array, when you define it, you have to define the type of data it's receiving. And I've used the same names to keep things simple. Okay, in theory, that should all work. But you might ask the question, you might want to ask a couple of questions at this stage. You're passing the array, but you're not handing it back. You're not returning it. So how is it going to update the right version? Well, watch this, because this introduces us to a feature of objects that's quite crucial. So let's say I put in 3, take 3 random numbers, different ones from before, and see if it, and it very happily displayed it. So this function could receive the array. It didn't need to get it back, right? But somehow it cleverly updated that one. It didn't create a copy of it when you pass it into here. This is not a copy of the array, though it looks like I've just passed a piece of data in. It's edited the actual value. Now this brings us to, and it's an advanced concept which we're going to come into a lot later. So this is a supplementary video, remember. But the concept here, to anticipate how this works, is that objects, they sit in memory. So if that's your RAM, it sits in an address in memory. So that's the data for that object. So if this is my integer array, right? It's sitting in memory with an address, a location. So when I have a method like populate array, and I pass my integer array into it, and you think, I'm passing a block of data. Am I not passing the data into that populate array method? No, this is the crucial element. I do not pass the object in. I pass the location or the address of the object. So this populate array can see the original object. Now that is a very critical concept. We will come back to that a lot. Objects, when you pass them in, and this is really, really important. I'll repeat it one last time. You do not pass in the data from the object. You don't pass all the numbers it stores. Because it's stored as an array and a location in RAM and in memory, you're actually passing the location of it around. So this receives the location. And once it receives the location, it can directly interact with the same piece of data. That is one of the powers of objects and this type of programming that Java does. That's why that simple line of code can replace that whole chunk of mechanisms. I can hide the mechanisms here, the actual process of how to populate the array, pass it my object, which is my integer array, and it will update it here. So we come back to the very last point here. You can as an exercise attempt to do the same thing with that. Display array. What would that look like if you created a display array? But now have a look at how this actually reads. You get the size. Okay, that's fairly clear what's going on. That line might be slightly obscure. You build an empty array, you populate the array, but then you have a whole bunch of mechanisms of displaying. So why don't we, to finish this example off, create our own display array method. Okay, and inside here, let's pass it the array. At the moment, it's not going to be happy with it because I don't have one. So let's grab that block of code, cut it from there, go down here, find the relevant space at the end of that particular function. So that method finishes there, so I need to go after that. And in the same way I have here, I had above me, I would create a public static void display array. And I'm going to pass it an integer array, and I'm going to call it int array just for simplicity, to say give it the same name, right? Int array. I'm going to grab, what did I do with that code? Hopefully I did grab it and it's in my, there we go. Index is internal, the length is internal. It needs a string value off. You don't need anything external. It needs print, but print is also a helper function, so it can access that. That's not a problem. That's public. So now that's the mechanism of displaying the array line by line. I now have my code here. Now have a look and ask yourself a simple question. How simple is this? That's the concept. That's the concept. That's the concept. That's the concept. The question is, how did it do it? All of that stuff is hidden away in different functions or methods. And this is a very common strategy. Let's run it just to make sure that I've done that correctly. Right. Oh, hang on. We're missing something. What are we missing? Oh, we didn't type that in properly. Okay, let's run it again. And the error in these inversions, so let's say, let's make it size 4 for a change, big number first, small number second, 4, and then say 77. And as you notice, it displays it. So everything works. Now, this type of exercise is absolutely crucial. If I were to encourage you to do one thing, I would encourage you to learn from this example. This concept in here about hiding the complexity is fundamental to learning the value of this whole way of programming in Java. Your names and concepts are very similar, and the body of the methods are the mechanisms and the processes of how to do it. So that's all hidden. And what you're going to learn about objects and object-oriented programming in time, in a few weeks, is that is built, this idea of managing this complexity and hiding mechanisms is fundamental to how we think and how we deal with it. Look at that, 4 lines of code to create this program. That's all I needed, because all the mechanisms are already built and I'm just using them. And that gives you an enormous amount of power. I can build up complexity, you can write really sophisticated programs if I have the right objects and methods, all holding the actual processes and mechanisms hidden from view. Okay, so we'll stop there, code this, and it will be a big challenge but worthwhile.